Good morning, students. Welcome my channel Bhuloks Mathematics. Last class I have already discussed some problems related to definite integrals. Let us come and start some new problems related to definite integrals. So write down question. Integration from 0 to pi by 2. Here it is root over of tan x plus root over of cot x dx. This is very important problem. So you see how can you do this problem. First of all, you have to break tan x is equal to sin x by cos x, cot x is equal to cos x by sin x. So integration from 0 to pi by 2. Here it is sin x by root over of cos x. Here it is root over of cos x divided by root over of sin x whole into dx. So you take the LCM. Integration from 0 to pi by 2. Here it is sin x plus cos x. Here it is root over of sin x into cos x. Okay. So now we have to multiply root 2 here. Sin x plus cos x. Here this can be written as 2 sin x into cos x dx. You see here root 2 cancel. So this can be written as like this. 2 sin x cos x. That can be written as, here it is root 2 sin x plus cos x dx. This can be written as 1 minus sin x minus cos x whole square. You see here a minus b whole square, a square plus b square minus 2ab, minus minus plus. So this can be written as like this. Sin square x plus cos square x, that is 1. 1 minus 1 cancel. 2 sin x into cos x, that is sin 2x, written as like this. So you have to take this as a t. Write down. Here it is 0 to pi by 2. Here it is also 0 to pi by 2. Then you have to take sin x minus cos x is equal to t. Once you put means you have to differentiating on both sides with respect to x. So dt by dx is equal to derivative of sin x is cos x, derivative of cos x, that is minus sin x, it is sin x. So dt is equal to sin x plus cos x into dx. Sin x plus cos x whole into dx. So once you take means you have to change the limit. Limit x tends to 0. Limiting value means upper limit, lower limit. X tends to 0, sin 0 0, cos 0 1. T tends to minus 1. Sin 0 0, cos 0 minus 1. T tends to minus. So when x tends to pi by 2, then t tends to sin pi by 2 0, sin pi by 2 1, cos pi by 2 0. That is t tends to 1. So the integral becomes root 2. Here in place of 0, x tends to 0, t tends to minus 1. When x tends to pi by 2, t tends to plus 1. So in place of sin x cos x dx, we have to put dt. Here it is 1 minus t square. 1 minus t square. So this is a even function. F t is a even function. So minus 1 to plus 1 We know one formula, integration minus a to plus a, fx dx is equal to 2 times 0 to a fx dx when fx is even and 0 when fx is odd. So here it is even function. So that can be written as root 2, here it is 2 times 0 to 1 dt by 1 minus t square. So integration of 1 upon 1 minus t square root 2 of r is equal to sin inverse t. 2 root 2, here it is sin inverse t evaluated from 0 to 1. Now we have to put the upper limit minus lower limit. 2 root 2, here we get sin inverse 1 minus sin inverse 0. Sin inverse 1 minus sin inverse 0. So whose value is 1? Sin pi by 2. So write down 2 root 2. Here it is sin inverse sin pi by 2. Sin inverse 0 is equal to 0. Sin inverse of sin bakso is equal to bakso. That is 2 root 2. Here it is pi by 2. Pi by 2. 2 to cancel. So that is root 2 pi. This is the answer of this question. So this is the answer of this question. Now let us take another question. Question number 2. Question, integration from 0 to 1 log 1 plus x divided by 1 plus x square into dx. This is a very important problem. So in this case, first of all, we have to put x is equal to tan theta. X is equal to tan theta. Once you take means you have to change the limit. Dx when x tends to 0, theta tends to 0. X tends to 1 means x is equal to 1, tan theta 1, theta tends to pi by 4. So differentiating on both sides with respect to theta. Dx by d theta. Derivative of tan theta sec square theta. So dx is equal to sec square theta d theta. So now the integral becomes, in place of x we have to put tan theta. In place of 0 we have to put 0. In place of 1 we have to put pi by 4. So that is I. Integration from 0 to pi by 4. Here it is a log 1 plus tan theta divided by 1 plus tan square theta. In place of dx, we have to put sec square theta d theta. 1 plus tan square theta, that is sec square theta. 0 to pi by 4 log 1 plus tan theta divided by sec square theta into sec square theta d theta. This cancels this. So integration from 0 to pi by 4. Here it is log 1 plus tan theta. Okay, this integral I have already worked out in one class. These problems I have already done. integration from 0 to pi by 4 log 1 plus tan theta d theta. This is one problem I have already worked out, whose value is write down pi by 8, answer value pi by 8 log 2. You have to check from the previous class the integral value of this quantity pi by 8 log 2. So converting this problem to this, whose answer I have already discussed in the last class. So you have to see from the previous classes. Now let us take another question. Write down question number 3. Integration question. Integration from 0 to pi by 2 x sin x cos x into dx divided by sin to the power 4th x plus cos to the power 4th x into dx. This is I. We know one formula, 0 to a fx dx is equal to integration from 0 to a f of a minus x dx. जोटी देखिबो x पकेइबो a minus x. So here it is fx. So जोटी देखिबो x पकेइबो pi by 2 minus x. So we get integration from 0 to pi by 2. ये pi by 2 minus x. Here it is sin pi by 2 minus x cos pi by 2 minus x divided by sin pi by 2 minus x whole fourth plus cos pi by 2 minus x whole fourth into dx. So that can be written as sin pi by 2 minus x, that is cos x, cos pi by 2 minus x, that is sin x. So the integral becomes pi by 2 minus x, here it is sin x into cos x divided by sin to the power 4th x